Hi. An urn contains 6 red marbles, 6 white marbles, and 5 blue marbles. A child randomly selects 3 without replacement from the urn. Round to 4 decimal places. Find the probability all 3 marbles are the same color. So the tricky part about this one is there's 3 different colors that could happen for, right? You could have all 3 red balls, all 3 white balls, or all 3 blue balls. So we really need to find the probability that they are all red, or the probability that they're all blue, or the probability that they're all white. And that probability is just going to be the probability that they're all red plus the probability that they're all blue plus the probability they're all white. And these are mutually exclusive disjoint sets. Like you can't be all red and all blue and all white. That you just can't do that. So these are, you don't have to subtract the intersection of these. So first you find the probability that they're all red. Well, there's 6 marbles originally that are red. So 6 plus 6 plus 5 would be all of the marbles. That's 12 plus 5, 17 out of the total 17 marbles. So the probability the first one is red is 6 out of 17. The probability the second one is red as well is 5 out of 16, because we took one of the red ones is now gone, assuming that the first one was red. For them to all be red, the first one would have to be red. And then, so you have 5 red left. And then you also have less marbles all total, so it's 5 out of 16. The third one being red would be 4 out of 15. So this is the probability that you know, because if they're all going to be red, that's equal to the probability the first one and second one and third one are red, right? Probably they're all red is the probability of first red times second red marble, the probability of the second one being red times the probability of the first one being red. Or third one. So if it's about probably all of 3 of those things happening, you would multiply the probability of each happening. And these are not independent. So that's why you see the probability for the second marble changing from the probability of the first one. It's different. So we really did kind of probability of the first marble times probability of the second marble, noting given the condition that the first marble was red. Okay, and then then we do the same thing for all the blue. So the probability they're all blue, there starts out 5 blue, so it's 5 out of the total 17. Then the second one being blue, and they're taking it out. This is without replacement. So it's 4 out of 16. And then the third one being blue is 3 out of 15. Plus the probability that they're all white, there's 6 white marbles. So the probability is first marble is 6 out of 16. 6 out of 17, sorry, then 5 out of 16, then 4 out of 15, just like you saw in the first one. So, good thing the denominators here are all going to be the same because it's just 17 times 16 times 15 is the denominator for all three of these things that we're going to be having to add together. So we can multiply that out, 16 times 17 times 15. And that's how we multiply fractions, by the way. You multiply all the numbers in the numerator, get one numerator, multiply all the numbers in the denominator, get one denominator. So I guess I could start with all the numbers in the numerator. It's 6 times 5 times 4, which is 96 in the numerator here, over the numbers 17 times 16 times 15, which is 4,080. Then 5 times 4 times 3 is 60. That's 5 times 4 times 3 from above. And then this is still the 17 times 16 times 15, which is going to be 4,080. And this is 6 times 5 times 4, which is the same as the first one, so that's 96. And then 4,080. Then we just have to add the numerators together and keep the denominator the same. So it's 96 plus 60 plus 96, which is 252. Over 4,080. And then we divide the 252 divided by 4,080. And I get this 0.06176. And they said round to 4 decimal places. So this is 1, 2, 3, 4. The 7 is the 4th decimal place. So I look to the 6, it's 5 or greater. So I add 1 to the 7. And then I get 0.0618. And there we go. There's our answer. Okay, oops, sorry about that. I made an arithmetic error here. 6 times 5 times 4 is not 96. It's actually 6 times 5 is 30, times 4 is 120. So I probably put in the calculator wrong, typo. Okay, which is of course changes our final answer here. So let me just erase this. Sorry about that. So 120 plus 60 plus 120, so that's 240 plus 60 is 300. And then 300 divided by 4080 is this 0.07352. And they said to 4 decimal places. So we want to be 1, 2, 3, 4. So we look to the 2 here and ask, is it 5 or greater? And it's not. So we just truncate the 2 off. We just chop that 2 off. And there we go. There's our final answer. All right. So that's for part A. Then part B says, find the probability that none of the 3 marbles are white. The probability that none are white we could use this if we wanted to, is equal to 1 minus the probability that at least 1 is right. Because either at least 1 is white, 1 or more are white, that is, or none are white. Those, I don't think I'm gonna use that. I'm just saying that if that makes things easier, we could use that. But all we have is the probability of it all being white up there, and that's not at least one white. So like, I don't think we're gonna use that. I don't think I'll use that here in this problem, but that can make our steps easier sometimes for some problems. But the probability that none of the three marbles are white. The thing that comes to my mind is like, well, let's see how many are not white in the urn. So there's 6 red that are not white and 5 blue that are not white. So we could just do 6 plus 5. That's 11 marbles. We'll be happy if we have the 11 marbles that are not white times by the over the total 17 marbles. And then if you pick one that's not white, that none are white. So they're assuming the first one is white. So then the next one would be 10 out of 16, and the next one would be 9 out of 15. Because they're taking the marbles out. It's without replacement. So there's one. Oh wait, if none are white, yeah, if none are white, then like you picked one of the 11 that was red or blue. And but then now there's one red or blue. So now there's only 10 red or blue left. And then you have to pick one then after you take out one of the second one is not white, red or blue. That means red or blue. Then there's only 9 red or blue left. And the overall total went down as well. So that's our answer here. And so we just multiply the numbers in the numerator, 11 times 10 times 10 times 9, and let's do them correctly this time. Let's do 11 times 10 times 9. That's 990. Ooh. And then 17 times 16 times 15 is that same number, 4080. And so if we divide that, it's 990 divided by 4080. So that's 0.24264. And the 4 is, so there's 4 decimal places, 1, 2, 3, 4 that we want to be accurate to. So we look to the one to the right of that, and it is not 5 or greater. So we just truncate it, and our answer becomes 0.02426. There you go. I hope you found this helpful. Bye.